With number 10, they are asking you to find all the rational zeros for each function. What that means, again, they just want you to identify all the p's over q's. So in this case, all the factors of p are going to be plus or minus 1, right? P being the 15, the final term, plus or minus 3, plus or minus 5, plus or minus 15. They're just asking you to find all the factors of 15. Now, because q is just plus or minus 1, right, being the first term, we actually don't need it because p over q is just going to be the same thing as p. So these are all the factors that you need. Whoops. These are all the factors that you need in order to start guessing using synthetic division. Now, we are going to synthetically divide this thing. I'm going to use my coefficients 1, 4, negative 8, negative 15. So 1, 4, negative 8, negative 15. And remember, when we do synthetic division using rational zeros, we are hoping for a remainder of nothing. So let's go and just start guessing. I'm going to guess 3. I mean, that seems to be a safe number. 1, 3, 12. It doesn't seem safe anymore. 36. Okay, that's definitely wrong. Okay, so let's try, how about 1? So I've got a 1, a 1, a 5, and then negative 3. That doesn't seem to work. Negative 3, let's try that out. So 1, negative 3, 1, negative 3, negative 24. So that doesn't work. So that means that the 3's are out. We tried positive 1. Let's try negative 1. So 1, negative 1, 3, negative 3, negative 11, 11. Man, we're not having a whole lot of luck here, unless I'm making a mistake somewhere. Let's try 5. 1, 5, 9. No, definitely not. Negative 5, 1, negative 5, negative 1, positive 5, negative 3, positive 15. Good. So now, since that one worked, x equals negative 5. Now again, on the final, remember, it could take you a couple of guesses. And, it doesn't make you any less capable. You're just, it really is just up to luck at that point. So from here, all of these terms get downgraded by an exponent. So it's going to be x squared minus x minus 3 equals 0. Now, I don't think this thing can be factored because the only thing that can multiply to 3 is 3 and 1. And there's no way I can get a negative 1 out of that. So I'm going to use either completing the square or the quadratic formula. I choose the quadratic formula because this thing is odd. So let's go ahead and do the quadratic formula. A equals 1, B equals negative 1, C equals negative 3. And so I get negative B plus or minus the square root of B squared, so that's 1, minus 4 AC, so 1 times negative 3 over 2A. Negative 1 is 1 plus or minus the square root of, this is 12, positive, right? Negative 4 times negative 3 is positive 12, so 1 plus 12 is 13 over 2. So my answers are negative 5 and 1 plus or minus root 13 over 2. That is how you do a P over Q substitution with rational expressions. All right? Are there any questions on that before we move on? Questions on that? Is this a matter of guessing? Raise your hands if you are comfortable with that. You've seen that before? Okay, good. All right. So let's try a different one here. Let's try number 19. 19 is a composition of functions. G of x is equal to x squared minus 5x, and then h of x is equal to 4x minus 4. Now, they are asking you to find g of h of x. Now remember, I told you guys to switch that notation into g of h of x. That way, I feel it's easier to identify which one's on the inside. In this case, h is on the inside, which means h is going to go into here and into here. So g of h of x is going to equal 4x minus 4 squared minus 5 times 4x minus 4. Raise your hands if you have any questions about that aspect. Jake. Okay. So let me... Okay. Okay, Jake, I'm gonna write this in a different color, okay? So h of x is going to be 4x minus 4, I believe. Yeah. Okay, so they're asking us to compose g of h of x. Jake, you see on the inside is the red function? So on the inside is this red function, so I'm going to plug the red function into here. So this x squared up top becomes something squared. Okay? Minus 5 times something. Right? Because the g of x is on the outside. And now that something that goes on the inside happens to be h of x. Well, h of x is 4x minus 4. Yeah? Okay. So now we have to FOIL this out. And I'm going to do this quickly. This is 16x squared minus, let's see here, 4 times 4 is 16 minus 32x plus 16 minus 20x plus 20. And now we just simplify it all out. 16x squared looks like minus 52x plus 36 equals g of h of x. Any questions about that? Another one like that? Sure. Okay, let's do something like, let's do something a little easier. Let's do something like number 12. So f of x equals 4x minus 5. G of x equals x minus 3. So they're asking us to find f of g of x. Okay, Jake, so you asked for this one. Let me start off with something a little easy. If I asked you for f of 1, what would that look like? Okay, this is the f function, right? Yeah. So what's f of 1? 4, plug in a 1, minus 5, right? Oh. If I asked you for f of 2, what is f of 2? 4 times 2 minus 5. Now, if I ask you for f of, everyone remember this? What is f of x plus h? Jake, remember what that is? 4 times x. Kaylin, you all right over there? Minus 5, right? Now, if I ask you for f of g of x. Okay, now forget about this thing for now. Forget about that. What would that be? 4 times g of x minus 5, right? Now, what is g of x?
4 times x, or 4 times x.
Replace it with x minus 3. Yeah. So this is 4x minus 12 minus 5. That becomes 4x minus 17. All right? Okay, so now let's move on to something. Okay. Let's do something like number 26. Determine whether or not the two functions are inverses. Okay, so typically the way we can compose, the way we determine function inverses is if I say if f of g of x equals x when it's all simplified, and g of f of x equals x, then they are inverses. Now, composing these two functions is awful. All right, so what we're going to do is we're going to choose a really which whatever function looks easier. All right, which function looks easier? Kylie, what do you think looks easier? F of x, the top one? Okay, we're going to find the inverse of this function and see if it matches g of x. Now, before we do that, I'm going to simplify g of x a little bit. See how there's a negative up top and a negative on bottom? Yeah? What I'm going to do is I'm going to factor the negative out of the bottom. So this is really negative 1 times x plus 2. All right? So let's see here. Let's erase that and rewrite it here. Negative 1 times x plus 2. And then that can now go away. What happens to the negative both top and bottom? Negative up top, negative on bottom. What's going to happen to those, Ryan? They become positive, so they cancel each other out. So we are trying to see if this function, when we invert it, looks like this. So for f of x equals 4 over x minus 2, I'm going to go ahead and write y equals 4 over x minus 2, and I believe it's plus 2 at the top, but minus 2 again. To find the inverse, I'm going to switch x and y, so it's going to be x equals 4 over x minus 2 minus 2. Oops, I'm sorry, thank you, brother. Y. I'm going to add 2 to both sides, so I get x plus 2 equals 4 over y minus 2. I have to get y to the other side, so I'm going to multiply both sides by y minus 2. So I get y minus 2, parentheses, times x plus 2 equals 4. Now, before you go foiling, remember, we're trying to get y by itself. So instead, I'm going to go ahead and subtract x, I'm sorry, not subtract, divide x plus 2 from both sides. So I'm going to get y minus 2 equals 4 over x plus 2. Last thing I'm going to do is I'm going to add 2 to both sides. And then that thing is going to go away. And that's what I end up with. 4 over x minus 2 plus 2. So let's see. Does that match what I was given? So does f of x match g of x? Do they match? They do. So the answer is yes. All right. Okay, let's take a look at something like number 41. 41 is going to be quick because it's a division problem, and if you can divide rational expressions, I trust you will be able to multiply them. Did I skip something? This is simplified expression. I'll go back to find the inverse of the functions. Hang on, I'll go back there. Okay. So, if you can divide, am I right in assuming if you can divide, then you can multiply rational expressions? So I'm going to go and flip the second, so I get x squared plus 13x minus 30 over 9x plus 90, and that's 9x plus 9 over x plus 1. So let's factor everything that we can. I believe the top left, everything except for the bottom left can be factored, so I'm going to pull a 9 out of here. X plus 1 over x plus 1 times x, let's see here, I think I wrote the problem down incorrectly, plus 30. This should be x plus 10 times x plus 3 over 9 times x plus 10. Okay, remember you can only cancel top to bottom or diagonally, so those are going to go away. The 9s are going to go away, and the x plus 10s are going to go away. You're left with x plus 3 as your answer. Okay, let's go over how to do inverse functions. If I do something like number 28, g of n is equal to 2n minus 1. I'm going to switch out g of n for y, and that's going to equal 2n minus 1. In order to solve for an inverse, we switch, in this case, n and y, so it's going to be n equals 2y minus 1, and then we just get y by itself. So we get n plus 1 equals 2y, divide everything by 2, so we get y equals n plus 1 over 2. So far so good? Alright, let's see here. Let's take a look at subtracting a couple of these expressions here. Let's take a look at number 52. 6k, or 6x I'll say, over x plus 6 minus 4x over x minus 2. Okay, before I subtract two rational expressions, what do I need? What do I need to subtract two rational expressions? Skylar? Common denominator. Skylar, are you thinking very hard right now? No, what's the common denominator here? X plus 6 and x minus 2. This needs an x plus 6. On the left, we need an x minus 2. So this is going to be 6x squared minus 12x. This is going to be negative 4x squared minus 24x. Because remember, I'm distributing a negative 4. All over my common denominator, which is x minus 2 times x plus 6. Let's combine some like terms here. Those are going to go away. You get 2x squared minus 12x minus 24 over x minus 2 times x plus 6. Now, something about this problem, maybe if I factored out a 2, I get x squared minus 6x minus 12. Yeah, Stephanie.
Where did you get the 24? Is it 24x?
Oops, thank you, Stephanie. That's what's messing me up here. Thank you. Okay, this should be 24x. So what you get is 2x squared minus 36x. Yeah? Okay, so now if I factor out a 2x, I get x minus 18. That doesn't help me, so it's gone. Yeah.
So on the test, if it doesn't really like cancel with anything in the denominator, we can just leave it.
Leave it like that if the factoring doesn't do anything for you. Exactly. Exactly. Good, good, good. Okay, let's take care of a complex fraction. Let's take care of something like number... that one's easy. How about something like number 62? X squared over 25 plus 9 over x squared all over 25. So let's go and find a common denominator here. What is the common denominator, Jordan?
X squared times 25.
Yeah, so what is this missing? 25. And what is this missing? X squared. So what I get up top here is x to the 4th plus 25 times 9. Is that 225? Yeah, it is. X to the 4th plus 225 over 25x squared all over 25. So now what you get is, I'm going to parachute this up to the top. This is times, let me see here, I'm sorry, this is divided by 25 over 1. So it's going to be, this doesn't clean up as well as I thought it would, x to the 4th plus 225 over 25x squared times 1 over 25. So this becomes x to the 4th plus 225 over 625 x squared. 25 times 25 is 625. Yeah, yeah. Okay, number 58. 16 over x over 16 minus 2 over x. So common denominator needs to be found on the bottom, so that's going to be 16x. This thing gets an x, this thing gets a 16. So I get 16 over x squared minus 32 over 16x. This top cannot be factored because 32 is not a perfect square, so I'm just going to multiply everything by the reciprocal. So this is going to be 16x over, I'm sorry, hang on, this is the, okay, so this is, sorry, I'm getting mixed up here. Okay, so it's really 16 over 1 divided by x squared minus 32x over 16x. And now I'm going to multiply it by 16x over x squared minus 32x. So now 16 times 16 is 256x over x squared minus 32x. And it looks like we can cancel some of the x's, so those can go away. So I've got 256 over x minus 32. Okay, go and keep working for a little bit. We'll come back in a few minutes. Okay, first thing I want to do is I want to fix something on here. Let's see here. I don't know where this x came from. It just kind of came up out of nowhere. So this is not the answer. The answer is actually, it should just be 256 over x squared minus, or 256x over x squared minus 32. Alright, so I made a mistake on that problem, so make sure you guys fix that. Okay, number 70. So this is going to be x plus 4 over x equals 1 minus 1 over x squared plus 5x. Okay, so David, first thing I'm going to do is I'm going to factor this out. So this is going to become x plus 4 over x equals 1 minus 1 over x times x plus 5. You good with that so far? Okay, so now I need a common denominator. Well, first of all, I'm sorry, I got to establish my domain. X cannot equal 0 or negative 5. Right? You got that, David? Okay. So now I need to get my common denominator. My common denominator is going to be x times x plus 5. So this side here needs an x plus 5. This middle term needs both. So once I have my common denominators, all the denominators can go away. I have x plus 5 times x plus 4 equals 1 times this whole thing is this whole thing, minus, well, the 1, it didn't need anything, so here's where we are. Dave, you okay with that so far? Yeah. All right. So now I'm going to go and FOIL this out. This is x squared plus 4 plus 5 is plus 9x plus 20 equals x squared plus 5x minus 1. I just distributed that. The x squareds are going to cancel each other out. I'm going to move 5x over to both sides. So I get 4x plus 20 equals negative 1. I'm going to subtract 20 from both sides. I get 4x equals negative 21. X equals negative 21 over 4. And does that interfere with my domain? Nope. So I'm good. You good with that, David? Okay. Yes, yeah. Domain is what x cannot equal. So after I factored it all, I set everything equal to 0 and I solved for x. So if I'm looking at the original problem here, this is x plus 4 over x equals 1 minus 1 over x times x plus 5. X can't equal 0, right? So x can't equal 0. X can't equal negative 5.
And you don't include the negative coefficients on the top, so it doesn't matter.
Nope, doesn't matter. Okay, all right. Hey, let's quiet down, please. All right, let's take a look at number section 8.6, which is the quadratic techniques. I'm going to do a few of these, actually. I'm going to start with number 18. R to the 2/3 minus 12r to the 1/3 plus 20 equals 0. Remember, in order to determine factorability, the middle exponent needs to be 1/2 the leading exponent, and in this case, it is true. So I'm going to create a thing being squared minus 12r to the 1/3 plus 20 equals 0. Does anyone know what goes inside that bubble? Skylar? R to the 1/3. So I factor this like I always do. This is r to the 1/3 and r to the 1/3. I need two numbers that multiply to 20, so that's going to be negative 10 and negative 2. These also add up to negative 12. So I get r to the 1/3 minus 10 equals 0. R to the 1/3 minus 2 equals 0. R to the 1/3 equals 10. R to the 1/3 equals 2. Since it's being raised to the 1/3 power, I'm going to cube both sides, so that's r equals 1. 10 to the 3rd power is 3 zeros, so 1, 2, 3. R equals 1,000. And r equals 8. Stephanie.
So, you don't need the plus or minus if it's a fraction, only if it's like...
If you are taking the square root of something, then yes, you need to include a fraction. So let's do an example of that, like number 15. Y to the 4th minus 3y squared plus 2 equals 0. I'm going to rewrite this, as negative 3y squared plus 2 equals 0. And I have my bubble being squared. What goes inside the bubble? Jake, what goes inside the bubble? Y to the 2nd, right? It's got to match up with the middle one. So from here, I've got y squared and y squared. My numbers are going to be 2 and 1 because those are the only two numbers that multiply to 2. My symbols are negative positive, which means on the inside they're negative negative. So I get y squared equals 2. Y squared equals 1. Now, I am going to take the square root of both sides. When I take the square root of both sides in the middle of an equation, I have to include plus or minus because the answer could have been positive, it could have been negative. Stephanie.
Can you do it like that, but like if it was like y squared equals negative something, like a negative number, instead of it equaling positive?
If it was y squared, say, equals negative 1, right, or negative 4, then you would take the square root of both sides. Y would equal plus or minus 2i.
If it was y third equals negative 4, would that be no solution? Or?
If it was y to the 3rd equals, say, negative 8, you would take the cube root of both sides. So y would equal negative 2. Right? Because negative 2 to the 3rd, Stephanie, is negative 2 times negative 2 times negative 2. So you can have a negative number resulting from an odd root.
But what if it was, like what if it doesn't have a cube?
If it was y to the 4th equals negative 16, something like that.
But does it equal, like if it was y to the 3rd equals like negative 9, you wouldn't be able to cube that evenly?
No, you wouldn't be able to.
So there'd be no solution?
No, it would just, if it was y to the 3rd equals negative 9, you would take the cube root of both sides, and it would be y equals the cube root of negative 9.
Oh. What if it was y to the 4th and like 16, like the problem that you had before?
Then you'd include an I, because that would produce an imaginary number.
I mean the outside, but like would it take the number with it?
So y to the 4th equals negative 16. We're going to take the 4th root of both sides. So because it's an even root, I need to include plus or minus. That's going to be 2i. Okay. So let's do something like 17. I like 17. M minus 9 rad m plus 8 equals 0. Now 19, which is similar to 11, forces you to make a conversion. What is the conversion that needs to be made? Stephanie?
The rad m is 1/2.
Yeah, rad m is m to the 1/2 power plus 8 equals 0. So now, oops, well, yeah, I can do it like that. What goes inside the parentheses? Elliot! M to the 1/2. Good job. Good job. I will tell Joshua's dad you got that answer right. So, my factors are m to the 1/2 and m to the 1/2. Looks like I'm going to have an 8 and a 1. Negative, negative. So, m to the 1/2 equals 8. M to the 1/2 equals 1. M equals 64. Now it's not plus or minus because I'm squaring both sides. It's m equals 64 and m equals 1. All right, I'm not taking the square root of both sides. I'm squaring both sides, so there's no need for plus or minus. Let's do a couple of interval chart problems. Inequalities. Whoa. Let's do something like number 57. Difficult one, or at least the most difficult they can make for you. We cannot cross multiply, so how do I deal with the 3 over x minus 1 on the right side? Let's see. Sayana, how do I deal with that 3 over x minus 1? Leanne? You subtract it from both sides. So you get 2x over x plus 4 minus 3 over x minus 1. Now, what is the most common mistake people make right now? Nikita? They don't find a common denominator. Make sure you find a common denominator, combine all your like terms, and then go for your critical numbers. So, common denominator this time is, Ryan?
X plus 4, x minus 1.
X plus 4 times x minus 1. So this needs an x minus 1. This needs an x plus 4. So I'm going to distribute this in. This is a 2x squared minus 2x minus 3x minus 12. All over x plus 4 times x minus 1, and that's all greater than 0. So now I'm going to go ahead and combine those. This is negative 5x. So I believe the top can be factored. I'm pretty sure it can be. So 2x and x. We're looking for two numbers that multiply to 12. So I'm going to say 3 and 4. This creates an 8. This creates a 3, which gives me negative 5, which is good, as long as 8 is negative. And that's all greater than 0. So what are my critical numbers up top and critical numbers on the bottom? Critical numbers up top, critical numbers on the bottom. Let's see. Mark, you got critical numbers up top and on the bottom? What's the one that you absolutely know? It's 4. Okay, who knows the other one? Kylie. Negative 3 over 2, which is negative 1.5. Just so that we know what we're dealing with here. On the bottom, it's going to be negative 4 and 1. Oh, man. Running out of space here. That's okay. Okay, so now I've got negative 4, negative 1.5, 1, and 4. So I'm going to partition this downward. And all my functions go in here. 2x plus 3, x minus 4, x plus 4, x minus 1. So now I need a number way to the left of negative 4, so that's negative 5 trillion. All 4 functions are negative. In between -4 and -1.5, say -3. -3 times 2 is -6, plus 3 is negative. See, -3 is going to be negative, positive, negative down here. In between -1.5 and 1 is 0, so there's positive, negative, positive, negative. So here, what did I say? Positive, negative, positive, negative. In between 1 and 4, let's choose 3. That's going to be positive, negative, positive, positive. And then 5 trillion beyond 4 is going to be all positive. My final intervals are going to be positive, negative, positive, negative, positive. Now, which intervals am I interested in? Alan, do you know which intervals I'm interested in? Okay, let's take a look. I'm looking for where this thing is greater than 0. It's actually the positive ones. Good job. So now, I need to write this in interval notation. So let me clean some of this garbage up before I do that. Okay, interval notation. The first one starts at -infinity. It ends at -4. I have to jump over this. So I create a union. And then -1.5, comma, it ends at 1. I have to jump over again. And then a union again. So I get 1, comma, I'm sorry, not 1. Should be 4, comma, positive infinity. And now, because the original problem was all greater than 0, non-inclusive, everything gets a soft bracket. I would expect a couple of these to show up in a couple of days. All right? Cool. I'll upload this right now, and we'll be all ready to go.